Lesson 2, graphing linear inequalities in two variables. So linear inequality means that you're going to have greater than, less than, or greater than equal to, or less than and equal to signs in it. And it's still a linear function, so it means it is still a line. So the first thing that we have to get familiar with is the three terms of types of numbers, the sets of numbers. So you have the set of real numbers, so that's all numbers, rational and irrational, positive, negative, and 0. So that's the element of R. I'll just write them down here as I'm talking. Sometimes you can write them with two R's, lines through the R, sometimes you write them just as an R. Doesn't matter. Next is the set of integers, so whole numbers, 1, 2, 3, and it could be negative as well, and 0. So no decimals. And whole numbers is all the positive integers, so nothing with a decimal and positive. So we're going to go through and we're going to determine what set of numbers this works with. There's also continuous and discrete. Continuous means that between every two numbers you can hit every single point. So if you can hit every single decimal as small and as tiny as it can go, that's continuous. Discrete means that there's separate, distinct parts, so you have to group them in one. Like, if you have people in a room, you can't have half of a person, so that would be discrete. So number of cars, let's do this first one. So number of cars, because you can't have half a car, it would be discrete. And it would belong to the element of the whole numbers. But it would have to be greater than or equal to 0. Because you can't make negative cars. Height of a plant. So height of a plant, you can hit every single point in between, so it would be continuous. And it would be an element of the real number because it hits every point in between. But because it can't grow negative, it would still have to be greater than 0. Number of snowboards, because you don't have half a snowboard, would be discrete. So it would be element of the whole numbers. We already know that those are positive. Distance traveled, because you can hit every single point between 2 points in a distance, it would be continuous. This would be element of the real numbers, but you can't travel negative distance, so greater than or equal to 0. And time driving, anything with time is always going to be continuous because you can always hit every part in a time. So there would be continuous, element of the real numbers, but you can't have negative time, so it's going to have to be greater than 0. Okay, for the chart under all of your definitions, it says graphing linear inequality. So if you have a continuous function, so continuous means element of the real number, and it's greater than and equal to or less than and equal to. Remember that little line underneath. You're going to shade with green and you're going to draw a solid line. So if you had a line going through, it would be solid and you would shade the underneath green. This is really hard to do on the iPad, so I'll show you a picture of it after. So you'd shade it all green. If you don't have green pencil crayons or orange pencil crayons, it is acceptable if you just shade it in very darkly so that I know that it is continuous. And if you write continuous underneath, I know what you mean. If it has no equal sign underneath, rather than drawing a straight line, you have to draw a dotted line. And then you can shade underneath. So it should be solidly shaded in underneath with a dotted line at the top. So if you shade it in properly, it should look something like this. So a clear dotted line shaded in underneath. A clear solid line shaded in darkly underneath. When you have discrete, so that means it's not continuous, you're going to shade orange with green stippling. I don't know how to say that word. Stippling? Stippling. That sounds better. And you're going to draw a solid line with the stippling with dots on it. So if you had this line, and you know it's straight because it's an equal sign underneath, so you're going to draw the stippling right on all of the corners. You're going to shade orange underneath, and then you're going to put dots at all of the intersections, meaning those are the whole values that you can use. So every intersection needs to have a dot. I'll show you a picture again after. If you don't have orange, shade lighter and put the dots in. That would be best, or you could even not shade and put the dots in and I'll still understand what you mean. Make sure you put the dots on the lines as well. I forgot to do that. For the second one, the only difference between this one is we don't have the equal sign, so it has to be a dotted line, and it does not contain the line. So you do not put any stippling on that line. And then the dots go underneath or over top, depending on what you found. So your graphs could look something like this. So light shading or no shading, but dots in every intersection. If you were shading with colors, this color would be orange, and the dots would be green. You cannot use pen when you do this. I expect it to be fairly neat. I understand we're not all the neatest people, but it has to be so neat that you always use a ruler, and it matters because it depends on what your values will be. If you're not doing it properly, I'm going to make you redo it. Okay, example 1. We have the inequality x minus 3y is greater than 6. Remember, for your signs, the little number eats the big number. And when you're reading it from left to right, if it makes an L, it'll be less than, in case you forget. So we are going to graph the line x minus 3y equals 6. And I'm going to do this in y equals mx plus b form first. So to do this, we're going to minus x from both sides. So we have negative 3y is equal to negative x plus 6, and divide both sides by negative 3. So y is equal to positive 1 over 3x minus 2. So that means that our rise is 1 and our run is 3, or negative 1 and negative 3. And our intercept is 0, negative 2. Our y-intercept is at negative 2. So we're going to graph this first. So draw in your line for your x and your y. We have a point at negative 0 and negative 2. And we're going up 1 over 3. Up 1 over 3. Down 1, left 3. So you're going to connect those points. Now, before we connect them, we're going to go through. So because it doesn't say anything, it doesn't have an element of a w or element of an I, we assume it means the element of the real numbers. So we know that it is continuous. Because there's no less than sign, we know that it's going to be a broken line. If there was an equal sign, it would be a solid line. So we're going to now draw our point. And we can draw it in green because we know it's going to be a solid, continuous function. So draw your straight line in. Next, we're going to decide where we're going to shade. So we have to choose a test point. So the best test point to see if it satisfies the equation is 0 and 0. So we're going to try 0, 0. It's the fastest one to do. So what happens is if the test point works, we're going to shade the side with 0 and 0. If the test point doesn't work, we shade the opposite side. So we have x minus 3y is greater than 6. So 0 minus 3 times 0 is greater than 6. 0 is greater than 6. This is not true. So what that means is 0 and 0 is not in the solution region. So because it's not in the solution region, we have to shade below the line. So we're going to shade underneath the line, and you can shade it in solid. Oh, and we have to make it a broken line. So just go in and erase to make it look broken. That's how I do it, honestly. Or draw it in broken to begin with. So we know it's continuous because we've shaded it solidly, darkly underneath. We know it's a broken line because there's no equal sign. And we know we shade below because that is the region we need to shade. To verify that it works, you choose a point in the region, say 1 and -3. If it satisfies the equation, you know you did it right. So let's just quickly verify. So x minus 3y is greater than 6. So x is 1 minus 3 times -3 is greater than 6. So 1 plus 9 is greater than 6. 10 is greater than 6. So this works. So if you choose any point below this line, it will satisfy your equation. For the next one, we have -2x plus 5y is greater than or equal to 10. So because it doesn't say, it's an element of the real numbers, so we know it's continuous. It has a greater than equal sign, so we know it's a solid line. And now we need to figure out how to graph the line. So we have -2x plus 5y equals 10. Again, I'm going to do y equals mx plus b form. So we're going to add 2x to both sides. So 5y is equal to 2x plus 10. Divide by 5. And y is equal to 2 over 5x plus 2. So our rise would be 2, and our run would be 5, or -2 and -5. Our intercept is at 0, 2. Now we are going to graph. So draw in your line, your x and your y axis. So we're starting at 2. You go up 2 over 5. We go down 2 over 5. There's not enough room, so it's kind of about right there. So we know it's solid, so we're going to graph a solid line in green. Now we need to determine, I can erase that, determine where we want to shade. So we want to find a test point. So we're going to use the vertex of 0 and 0. So -2 times 0 plus 5 times 0 is greater than or equal to 10. 0 is greater than or equal to 10. This is not valid. So rather than shading above, or rather than shading where 0 is, right here, we need to shade above the line. So anything above the line. So we know it's continuous, so we shade in solid above the line. Now we need to verify our point. So we could choose the point 1, 1, 2, 3, 4. 1, 4. You can't really see that. So if we were to verify that, and it's important to do this, verify. We have -2 times 1 plus 5 times 4 is greater than or equal to 10. -2 plus 20 is greater than or equal to 10. 18 is greater than or equal to 10. So that's right. It's also important if you label your line. It helps keep things organized. So somewhere along the line you should write negative 2x plus 5y is greater than or equal to 10. I think I forgot that in the last one. You should do that. Okay, for this graph we have a lot of squiggly brackets and things that look unfamiliar. So the way that this reads is that x and y such that x minus 2 is greater than 0, and x is an element of the real numbers, and y is an element of the real numbers. So we need to first determine if it's continuous or discrete. Because these are element of real numbers, we know it's continuous. It's just a greater than sign, so it will be a broken line. And now we are going to graph x minus 2 is equal to 0. So if you rearrange this, it's x equals 2. Now that is just a straight line that goes through every x point. So if we were to draw our x-axis and our y-axis, what that means is where x is 2, it's 2 forever. No matter what your y is, every single place up and down. So you want to draw with green, because it's continuous, a broken line through the point x equals 2. So anytime you have an x equals something, it's going to be a horizontal line. And I meant to say vertical. Anytime you have y equals something, it would be a horizontal line. Just a note. Now we still need to find a test point to see which side to shade on. So we can still choose 0 and 0. So if 0, x minus 2 is greater than 0, 0 minus 2 is greater than 0, minus 2 greater than 0. So because that's not true, we need to shade to the right of the line. So shade right. And we should still verify. And please shade this in properly. I can't on the iPad. It's impossible. If we verify this point, 3, 1, 3 minus 2 is greater than 0, 1 is greater than 0, that works. So anything to the right of this line will work.